Okay, so before we get into the next integral rule, Chapter 5, you've learned new derivative and integral rules. Your derivatives from Section 5.1, the natural log of u or the natural log of the absolute value of u have the same derivatives. Section 5.3, we looked at the derivative of the inverse function, and then just yesterday in the same lesson, 5.4, we looked at the exponential function e to the u. Integrals. In 5.2, we learned to integrate 1 over u, and that completed our power rule. All right, because we know for our power rule, we can't add 1 and divide by the new exponent here because we would be attempting to divide by 0. So that's where our natural log of the absolute value of u. And then I just put your new trig integrals on there as well. All right, we again were able to integrate them now that we had the log rule. Notice that each integral, as we've discussed, has the natural log in it. All right, our properties, these were discussed at the beginning of 5.1, just your natural log properties. We use this on the quiz and in classwork. Natural log of the product of expressions, we break that up by adding the natural log of the individual expressions. And now with e, we're going to look at similar properties. All right, e to the a plus b power is the same as e to the a times e to the b. All right, exponent rules. When you're multiplying like bases, we know that we add those exponents together. And then when we divide like bases, we know those exponents are subtracted. So these will come in handy in this lesson. Okay, so if the derivative of e to the u is e to the u times u prime, what do you think the antiderivative of e to the u is going to be? So the antiderivative of e to the u is even easier than the derivative. It's just itself, e to the u plus c. All the hard work for this is actually determining what u and du are and making that proper substitution. But the integral itself is very simple. All right, so let's look at some examples. E to the 2, e raised to the 2x power. So start with an easy one. We're going to pick our u as the entire exponent. So u would be 2x, du would be 2 dx. So solving that equation for dx. So I have e to the u power times du over 2. Bring the 1/2 out front. And then the antiderivative of e to the u is just itself. The only thing you have to make sure you're doing, replace that u to be in terms of x again, plus c because it's an indefinite integral. Now, here we have x times e to the x squared. Again, when you see e, always start with your u to be that exponent. Won't always be the case, but it'll be the best place to start. Makes du 2x dx. Solving that for dx. So we have the integral of x times e to the u, replacing dx with du divided by 2x. My x's cancel, so I know my u substitution was correct. And now the actual integral looks exactly like the last example. So 1/2 e to the u, and then just replacing that u with the appropriate substitution. Now remember, with any indefinite integral, we can check all our answers by deriving the solution. So 1/2 is a coefficient that stays put. Now the derivative of e to the u is itself times the derivative of the exponent. The derivative of c is 0. These two 2's cancel, and we do in fact end up with the original integrand. Okay, now here, a couple things we've talked about with u substitutions throughout the chapter. We're not going to pick u just to be equal to x. All that does is changes the variable inside the integrand, but it doesn't simplify the integrand at all. Alright, so there fails our method that pick your u to be the exponent. Let's think of the other integral rules we've had. So I'm going to let u be the entire denominator. That makes du e to the x dx. Solving that for dx. Now let's look at our u substitution. E to the x over u times du over e to the x. We got the appropriate terms to cancel. So our u substitution would be 1 over u du. And now the antiderivative of 1 over u is the natural log of the absolute value of u. So final step, replace that with e to the x plus 1. So remember, they're just new integral and derivative rules. They can be combined with anything else that we study. Alright, this one's nasty looking. We have the numerator separated with a minus sign, the denominator separated with a plus sign. So I'm going to default to pick u, start with the denominator always. Makes du, derivative of e to the x is itself, derivative of e to the negative x is itself times the derivative of the exponent, which is negative 1. So now look at what we have. E to the x minus e to the negative x. E to the x minus e to the negative x. That whole statement I'm going to replace with du. So as we continue to do u substitutions, we don't need to introduce anything here. Let me get out my highlighter. So let's just go right to our replacement. Denominator was picked as u, and then what we need to make that replacement for du we have exactly. So natural log absolute value of u, natural log absolute value of our original u substitution. Alright, solve the differential equation. So we're given the second derivative as sine of x plus e to the 2x, and then we're given these two conditions. So solve the differential. Going back to, this would be the particular solution. So we're looking for f of x to equal some function. So where do we start? Let's find the antiderivative of the second derivative. Antiderivative of sine of x is negative cosine x. Alright, so we would look at this as the antiderivative of each term. So e to the 2x, that needs a substitution. This is actually the first example we started with. So I need a 1/2 out front. Antiderivative of sine is negative cosine plus 1/2 e to the u plus c. So now what's the antiderivative of the second derivative? That would give us f prime. Now we have our condition. When x is 0, the first derivative is equal to 1/2. Cosine of 0 is 1, so I have negative 1 plus 1/2. Anything to the 0 power is 1 plus c equals 1/2. So c is going to equal positive 1. Alright, so same conditions. Our first derivative, negative cosine of x plus 1/2 e to the 2x plus 1. Alright, so now how do we get f of x? Let's integrate the first derivative. Again, just looking at each piece individually. The middle term will need the u substitution, so u is going to be our exponent it makes du 2dx, which means I would need to introduce another 1/2 out front to make the proper substitution. Antiderivative of negative cosine would be negative sine of x. Now I have plus 1/4 e to the 2x. Antiderivative of 1 is x, and then I need my plus c. So that's the general solution for f of x. Now let's plug in our condition. When x is 0, f of x is equal to 1/4. Sine of 0 is 0, e to the 0 is 1, so we get c to equal 0. So our general solution and our particular solution are almost identical. Alright, so let's look at another one. Antiderivative e to the secant of 2x times secant of 2x tan of 2x. There's a lot going on here. There's a lot of possibilities that we could begin for u, but let's stick with choose the exponent first. If that's not right, then you can look at other values, substitutions for u. So du, derivative of the secant function, is secant of u, tangent of u. Using the chain rule, the derivative of 2x is 2. So du tan of 2x equals dx. So we have the secant of 2x, the tan of 2x, and the dx. So they will be replaced. We just need the 1/2 out front. So 1/2 e to the u du. And like I said to start the video, the hardest part about these problems is choosing the correct u. The antiderivative of e to the u is very simple. It's just itself. Alright, so now we have 1/2 e to the u. It's a definite integral, so let's look at our fundamental theorem. I'm going to keep the 1/2 out front. E to the secant, 2 times pi over 2 is pi, minus e to the secant of 2 times pi over 3 is 2 pi over 3. So secant of pi, that's secant's reciprocal of cosine. Cosine of pi is -1, so we have e to the -1. Secant of 2 pi over 3, that's a reciprocal of the cosine. 6, 4, 3. Cosine of pi over 3 is 1/2. 2 pi over 3 is in the second quadrant, so the cosine is negative. So this would be minus e to the -2. Now just writing your answers with positive exponents, 1 over e minus 1 over e squared. So this would be our final answer. Alright, I'm going to give you a couple homework problems. Please jot these down and complete for next class. Two indefinite integrals, two definite integrals, and then solve the given differential equation where a is a real number. Okay, so a can be any real number. See you tomorrow.